So the while loop is the other major looping construct in R, and the basic idea is that the while takes a logical expression and will execute the loop based on the value of that logical expression. So for example, I've got a very simple loop here. It initializes a count variable equal to 0, and then while that count is less than 10, it prints out the count and then increments the count by 1. So as soon as the value of count gets to 10, the loop stops, and then it'll go on to the next body of code. So the while loop is useful because it makes things easy to read sometimes. It's very obvious here that this loop is supposed to stop working or stop executing when the value of the count variable is 10 or more. So it makes it a little bit more readable. However, you have to be a little careful with while loops because technically speaking, they are infinite loops and you have to make sure that the condition that stops the loop will actually occur. Otherwise, your program will never finish. And so in this case, it's fairly obvious that the loop will eventually stop executing. But in much more complex pieces of code, it can be hard sometimes to figure out whether the while loop will finish. And so often it's safer to use something like a for loop that has a hard limit on the number of times it can execute. So that's not necessarily saying that you should never use a while loop, but you just have to be careful when you do use them. So you can test multiple conditions in a while loop or in any type of construct like an if statement, for example, by using the logical operators. So here I've got a variable z, which I initialized to the value 5, and the condition for the while loop is basically while z is greater than or equal to 3 and it's less than or equal to 10. So while it's between the values of 3 and 10, then what I'm going to do is going to print the value of z. I'm going to flip a coin, a fair coin. And if the coin is a 1, I'm going to add 1 to my value, and then if it's less than 1, if the coin is equal to 0, or any other value for that matter, I'm going to subtract 1 from z. So this is, I'm generating a little random walk here, and the value of z is going to go up or down depending on my little coin flip here. So here you can see it's a little bit harder to tell when the while loop will finish, because the body of the while loop involves random number generation. So here the z value is going to zigzag up and down until it eventually hits 10 or eventually it hits 3 or something less than 3. And so this may be kind of nice, but you have to be careful that it doesn't go off for too long. So one thing to note on a more technical level is that the conditions when R tests the condition in a kind of a multi-expression condition. Here I've got z greater than or equal to 3 and z less than or equal to 10. The conditions are always evaluated from left to right. So it checks to see if the leftmost condition is true, and then it goes to the next condition. So first it'll check to see if z is greater than or equal to 3. If that's true, then if that happens to be true, it'll go to the next expression. It'll check to see if z is less than or equal to 10. So if those are both true, it goes on to the next into the body of the loop. Repeat is a construct that basically initiates an infinite loop. This is not what I would characterize as a commonly used control structure in R, but it does have its use occasionally. So the only way to exit a repeat loop is to call break. So obviously you're going to have to call break at some point, unless you feel like running your program, forever. So here is a pretty simple example. Here I'm initializing a value of x0 to be 1, and I'm setting what I think of as a tolerance to be 10 to the minus 8. And then I'm going to repeat the following structure. Basically, I'm going to imagine that there's some function that computes an estimate for x, and then I'm going to call that x1. And basically, if the new value of x, that is x1, if the absolute value of the difference between x1 and x0 is less than some tolerance, in this case 10 to the minus 8, then I'm going to stop the loop and then move on to the next bit of code. If the difference is greater than my tolerance, then I set x0 to be equal to the new value, and then I run the loop again. I calculate a new estimate, and I check to see if the difference is small. So this is a common type of formulation in many types of optimization algorithms. So for example, if you're trying to find the solution to some set of equations, or you're trying to maximize a function, often you'll iterate over and over again, and you'll stop when the estimates that you're calculating are getting closer and closer together, because that's usually a sign that you're kind of converging to whatever the minimum or maximum of the objective function is. So in theory, this is a perfectly reasonable construction. You want to keep cycling through the algorithm until the two values are close. So there's one problem, which is that, first of all, it requires an algorithm that is guaranteed to converge, and not necessarily every algorithm has that property. Second of all, also, it does depend a little bit on the tolerance, so the loop will run longer if the tolerance is smaller, generally speaking. And because it's hard to predict how long this loop will run, it can be a little bit dangerous because it's unpredictable. It could theoretically run forever, and you have no way to guarantee that the program will stop at some point. So this construct, although it's theoretically kind of the right thing to do, it's usually not a good idea. It's probably better off to use a for loop that has a hard limit on the number of iterations that it's allowed to run. That way, if you have a problem with your algorithm, it will eventually reach the hard limit and stop, and you'll know that the reason it stopped is because it didn't converge, and then maybe you can try to fix something about the algorithm. With the repeat type of approach, if your algorithm is not converging, you won't have any warning. It'll just be running a really long time. The last control structure element I want to talk about is next, and then there's also return. Next is basically used in any type of looping construct when you want to skip an iteration. So here I've got a basic for loop, which is going to run for 100 iterations. And then, but the idea is that I want to skip the first 20 iterations and then only kind of execute some code for iterations 21 through 100. So here I've got a very simple if condition. So if I is less than or equal to 20, I'm just going to skip. So I use the next expression, and it'll skip everything else in the for loop and go and iterate again. So once I gets beyond 20, then of course the expression I less than or equal to 20 will be false, and so it won't execute the next. It'll go into whatever the body of the code for the for loop is. So next is a way to skip an iteration in a loop, and of course break is a way to execute exit the loop entirely. The return function is another function that can use to be exit a loop, and it's primarily used to exit a function. So it'll exit the entire function and return a value that you pass it. So we'll talk more about return when we talk about functions, but it's something that can interrupt the flow of a program too. So that's control structures for now. So the basic summary is that control structures like if, while, and for that can allow you to control the flow of an R program. Generally speaking, while there are constructs that kind of allow you to execute infinite loops, you generally want to be on the lookout for these kinds of things and to avoid them if possible, even if they are kind of theoretically correct, because they can lead to kind of some unpredictable behavior in programs. And the other key thing I haven't mentioned yet is that the control structures that I've mentioned here are primarily useful for writing programs. I think I mentioned that in the beginning. But for command line and interactive work, there are other types of looping type functions that we can use. They generally have the word apply in them, and they can be a lot more useful for command line interactive work when you're exploring data and things like that, not writing programs, although they can be very useful in writing programs too. So I'll talk about the apply functions in a separate set of videos.